contemporary requirement for rich internet application engineering, presented by Mr. Dissanayake, who is presently attached to Informatics Technology as an assistant lecturer, and he had Open Technology from Sri Lanka Institute of Information Technology in 2007. He had authored about 20 peer-reviewed conference papers and journal papers, and his research interests are in software architecture, web engineering, rich internet applications. And at the moment, he is reading for his MPhil at University of Columbus School of Computing. You may proceed with the presentation.
Thank you, Chair. Good evening, everyone. So that my topic is abstract concepts, a contemporary requirement for rich internet application engineering. This is entirely a conceptual work, so I'll try my best to convey the idea behind the topic. So I'll be giving an introduction, then talk about the conceptual abstraction and the advantages of the conceptual abstraction and abstract concepts available for rich internet applications. Then finally I will provide the conclusions. So let me start with the background of the rich internet application. So we call them RIAs. So that most of the web applications nowadays, including Facebook, Google Apps, Yahoo, they are rich internet applications. So I think that everybody is familiar with rich internet applications these days. So they have rich UIs and they have faster synchronous communication capabilities, and they eliminate page refreshes and workplace patterns via partial page rendering using the synchronous communication capabilities, and altogether they provide enhanced user experience. And they use Ajax, polling, server-side events, WebSocket-like technologies and techniques to implement this asynchronous communication. Looking at the downside of these rich internet applications, they are really complex. There are various components integrated in diverse ways within these rich internet applications. To overcome the complexity, there are numerous tools, libraries and frameworks available, and they are depending on some dedicated techniques and technologies. So let me use the acronym for that, TTs. Right. So the available tools, libraries, frameworks and TTs, however, we have to note that they do not improve the underlying concepts of RIAs. So that furthermore, it has been already noted, identified that proper guidelines, established software engineering methodologies and solutions, and concepts like architectural styles or design patterns are largely lacking for RIAs at the moment. And there are some concepts available, however, these available TTs do not describe how to overcome the complexity in designing and development aspects of the RIAs. And the conceptual solutions available, that at the moment in the domain there are few conceptual solutions available, but they are also TTs dependent. So we'll talk about what's this TTs dependent in a moment. And in this background, it makes the available tools, libraries, frameworks, concepts and other solutions to be TTs dependent, thus not abstract. So it leads to many disadvantages. I will be talking about these disadvantages. So to overcome these cons, what we suggest is it's a contemporary requirement for RIA engineering to have abstract concepts such as architectural styles or design patterns and algorithms. Moving into the methodology of this work, we conducted an intensive literature survey focusing on RIA TTs like Ajax and WebSockets and available tools, libraries and frameworks in order to identify their functionalities, features and how they work, their specifications. And even though this is a conceptual work, in order to gain some empirical evidences, we conducted a series of experiments. It's prototype based and iterative and incremental, focusing on the underlying architectural formalism of the RIAs. So we identified some issues in the literature survey, and we wanted to get some experience, our own experience. So these identified issues were tested in early iterations, and we identified some solutions for them, and they were refined in later iterations. Moving into the conceptual abstraction. Before talking about the conceptual abstraction, we need to have a good idea about the TT's dependency. So the best way to talk about the TT's dependency is using an example. So I have selected this Oracle's Model 2 architecture. So you can see there are some components within this architecture. Action servlet, JSP views, Java beans. So this architecture is purely based on Java and related TTs. So we can say this architecture is TTs dependent. There is a dependence between the architecture and the TTs. So that we are interested in abstract concepts, which are not this. The word abstract is used here in order to denote the TT's independency. So for an example, object-oriented designing and development or the client-server architecture, they can be seen as abstract concepts. They are not depending on any TTs. Talking about the advantages of this conceptual abstraction, so here we are focusing on the conceptual abstraction for RIS specifically. So this conceptual abstraction of common characteristics of RIS needed at the moment. So we need to realize the abstract features of the RIS, and we need to realize the architectural formalism inside the RIS. So we think this can be achieved via understanding the common characteristics and essential features of the RIS. So at the moment we have already published a paper about common characteristics and essential features for RIS. So that having this knowledge, the knowledge about the common characteristics and essential features, so it can increase the realization of the RIS. So it can provide the realization of the processing components and communication connector components and data elements and their configurations. Configuration means the relationship between these components. So that can be seen as the first advantage of the conceptual abstraction. And then we can gain knowledge sharing advantages. So transferring knowledge and experience from one environment to another environment is relatively easier when we have abstract concepts. So we do not need to worry about the TTS anymore. So it's a matter of adapting TTS into the concept instead of adapting concept into the TTS. For an example, if you take the same Oracle's Model 2 architecture, so you use it in a Java-based project and you want to apply it into a PHP project or maybe .NET project. So you have to think how this concept should be adopted into the environment first, right? But if it's an abstract concept like client-server architecture, it's just a matter of applying the TTS into the concept. As a result of this easiness in knowledge sharing, we can have lower learning curves, right? So once you apply client-server architecture in one project, you can easily adapt it into another project. Right? It helps you to lower the learning curve, and it also affects new RIS and TTs based on the concepts. Then the third advantage we have identified is assist in better TT selection and adoption. Right? So TT's dependency provides flexibility in incorporating available TTs. Right? So we have at the moment we have some technologies and techniques. So it's just a matter of identifying what are the suitable TTS you need to be adapted into the project. And it will also assist in understanding the adoption of the new TTs introduced in the future. For an example, say that object-oriented concept. Right? So we know that we know how to use object-oriented concepts in Java or maybe C#, like .NET platform. Right? Another language is introduced which is based on object-oriented concept. So you can easily learn this. You can easily learn how to adapt object orientation concept into the new language. So we have, as I told you a little moment ago, that we have identified some abstract concepts which are suitable for RIS and what we think as a contemporary requirement. Algorithms, right? So I think everybody is familiar with algorithms, like searching or sorting algorithms. So we think algorithms can be used for asynchronous communication handling in the client side as well as asynchronous communication and processing in the server side. at the moment we have identified few algorithms and we are working on refining on them. And the second abstract concept is design patterns like GUI patterns and CRUD pattern. So at the moment there are lots of GUI patterns available for rich intent applications. And furthermore, we think design patterns can be used for server-side business logic processing as well. And the third one is the architectural style, like client server or MVC. So we think it can be used for AJAX or WebSocket-based asynchronous communication connector component designing and development. Our ongoing research is also about designing an abstract architectural style for rich intent applications. So based on these facts, let me conclude my talk. So we think that the DT's independency can provide advantages. Therefore, the abstract concepts can provide many advantages for the environment of rich intent applications engineering. So we think that the abstract concepts is a contemporary requirement in the domain of RII engineering. So at the moment we have enough tools, frameworks, libraries, techniques and technologies. So what's lacking is concepts, abstract concepts. That's the end of my talk. Thank you very much. And not only the question, if you have any feedback, they are also appreciated since this is an ongoing research.